Yeah, so hi all, welcome to the lecture series on solving the previous year questions of GATE ECE, and we were solving the questions related to analog circuits, and we were solving the question related to op-amp circuits, right? So let us continue that. So today this is the first question that we are going to solve today, and the question is from GATE 2021. Okay, so the question is, consider the circuit with an ideal op amp shown in figure. So this is the figure circuit given, and we have here a V in voltage source and VRF voltage source, and two resistance R at the input and RF at the feedback. Yeah, fine. And here the question is, assume V in is much less than VCC and Vref is much less than VCC. That is, magnitude of V in and Vref is much less than the magnitude of the supply voltage or the DC bias voltage. The condition at which V out equals to 0 is, so question is, what is a condition at which the V out equals 0? So we will solve this. So if we see here, it's a negative feedback circuit, right? That the feedback resistance RF is given to the inverting terminal and the non-inverting terminal is connected to ground. Okay, so what happens, the ground connection, this voltage is 0, so here also virtual ground, so this voltage is 0, right? So and here the V in, there is a voltage source V in and Vref. So what is a current flowing like this? This current I will call it as I1 and this current as I2. So this node is virtual ground. So the current I1 I can write as I1 from the circuit as this node voltage minus this node voltage by resistance. So what is this node voltage? That is V in. So V in minus 0 by R. So that is V in by R is the, so they have written as capital V. V in, okay, V in by R is the current I1 and current I2 is, so here this node voltage minus this node voltage by resistance R, right? So this node voltage is minus Vref, because it is, here it is minus and here it is plus. So minus Vref minus 0 by R, or minus Vref by R is the current I2. And since this current I1 and I2 reaches here, the current going to the inverting terminal is 0, right? So both the current will flow through R of resistance and this will be plus minus, okay, and this resistance is I1 plus I2, okay. So from the circuit it's seen, it can be seen that what will be the V out now? V out will be the voltage across the resistance RF itself. So from the circuit, V out we can write as minus the current through RF, that is I1 plus I2 into RF, minus of I1 plus I2 into RF. So I will substitute this, minus V in by R plus minus Vref by R into RF, okay, and I will take R outside, so within bracket it will be V in minus Vref into RF by R. Fine, so this is V out. Okay, so the question is, what is a condition at which V out equals 0? When does V out equal 0? That is when this bracket term is equal to 0, right? So V in minus Vref equal to 0, or it indicates V in equal to, or it is equal to V in equal Vref. Okay, so V out is 0 when V in is equal to Vref. So answer is option A. Yeah. So that is question 1. Now we will solve the question 2 of today's lecture. So this is from GATE 2020. So the question is, the components in the circuit shown below are ideal if the op amp is in positive feedback and the input voltage Vi is a sine wave of amplitude 1 volt, the output voltage V0 is. So given this is an ideal op amp. Okay, so I'll call it as OA1 is ideal op amp, and Vi is the input signal of having amplitude 1 volt, and Vout is the output voltage. Now if you carefully see here, the feedback is connected at the non-inverting terminal plus, and at inverting terminal it is connected to ground, right? So what happens, it in this configuration, V minus won't be equal to V plus. So what is V minus? V minus is the voltage at this node, and V plus is the node voltage at this node. Okay, that is, it won't follow the virtual ground concept. Okay, and how it works? It works like a comparator, right? It works like a comparator. That is, when V plus is greater than V minus, V out will be some plus V sat, and V plus is less than V minus, the V out will be equal to minus V sat. Okay, so what is V plus here? Okay, yeah, so what is V plus here? So if you see here, so I'll draw it and draw the circuit here again. Okay, so this is V plus, the current here is 0, right? So this is Vi, and this is 1K, this is 1K, this is V0. So I will apply the Kirchhoff current law here. Okay, current law at this node. So what happens? V plus minus Vi, okay, by 1K is the current flowing like this, plus the current flowing like this, that is V plus minus V out by 1K will be equal to 0. That is what Kirchhoff current law states. So on rearranging, I will get V plus, so 1K can cancel, right? So okay, so 2V plus equal to Vi plus V0, fine, or V plus is equal to Vi plus V0. So this is what I have got. So we'll just analyze this. So we'll consider two cases. So I have V plus is equal to Vi plus V0, sorry, by 2 is there, okay. So by 2, yeah. So say V0 is plus V sat. Okay, so here plus V sat is here it's ideal, right? So it's plus VCC and minus VCC is 5 volt. So we'll say like this is equal to plus 5. Okay, so what happens? V plus is equal to Vi plus 5 by 2. Okay, now Vi has two conditions, that is Vi can either be maximum values of 1 volt or Vi will be equal to minus 1 volt. So if I substitute 1, V plus will be equal to 6 by 2 or 3 volt. Okay, or when I substitute Vi equal to minus 1 volt, V plus will be equal to minus 1 plus 5, that is 4 by 2, that is 2 volt. So in either case, V plus is greater than V minus, which means V out will stay at plus 5 volt itself. Fine. So this is one case. Now if I consider the other case, that is when say V0 is minus V sat or is equal to minus 5 volt, what happens to V plus will be equal to Vi minus 5 by 2. Okay, so again I will consider V minus equal to 1. What happens? V plus will be equal to Vi sorry, not V minus, it is Vi, right? Vi equal to, okay, so yeah, so when it is 1, it will be minus 4 by 2 or minus 2 volt, and if it is Vi is equal to minus 1, V plus will be equal to minus 1 minus 5, so minus 6 by 2 or minus 3. So in either the case, the V plus is less than V minus, or which means, okay, so which means V naught will be always equal to minus 5 volt. So whenever Vi is right, so if, which means if V naught is plus 5, it will remain at plus 5, right. Whether Vi is 1 or minus 1, the V plus is always greater than V minus. And if V naught is equal to minus 5, right, V plus is always less than V minus, which means it will remain at minus 5. Fine. So always V naught is a constant, either plus 5 or minus 5, and it depends, like if initially it was plus 5, it will remain at plus 5, or if it was initially minus 5, it will remain at minus 5. So the answer is, it's a constant and remains either at plus 5 or minus 5. Fine. So this is how we solve this question. Let us come to the next question, that is third question. Again, this is from GATE 2020. So in the circuit shown below, all the components are ideal. If Vi is plus 2 volt, the voltage the current I naught sourced by the op amp in is dash milliampere. Okay, so what is I naught? I naught is this current. Okay, this is the I naught current. Okay, so if you see here, the op amp is in non-inverting configuration, right? Vi is given here at the non-inverting terminal, and this voltage is equal to 2 volt. Okay, so if this is 2 volt, and if you see here, it is the feedback is connected to the inverting terminal, so it's a negative feedback amplifier, right? So whatever is a voltage here, the same voltage will be reflected here due to the virtual ground concept. Okay, so the voltage here will be 2 volt itself. Here also the voltage is 2 volt. So if this is 2 volt, here plus minus it will be 2 volt, right? So the current, okay, there will be a current flow. So let me draw here again. Minus plus, there is a resistance here like this. So 1K, this is Vi, that is equal to 2 volt, and this is I naught, and this I will call it as V naught. Okay, so this is 2 volt, so there is a current flowing like this. Okay, so what is this current? The voltage across 1K is now 2, right? So 2 by 1K, or it is equal to 2 milliamps. So 2 milliamps current is flowing through this resistance. Since this is ideal, what is the current going here? It will be 0 ampere. So the entire current flows through this resistance. Okay, so what is that current? So the current direction that I have drawn is wrong. The current direction is like this, because it is pulling the current from output. Right, so this current will flow like this from V out, and it will enter here, and it will flow like this to the ground. Okay, so this current is 2 milliampere. Okay, now since this is a non-inverting configuration, what is V naught here? V naught will be the voltage, input voltage 2 into 1 plus Rf by R1, or 1K is the Rf by R1 is the 1K. So 2 into 1 plus 1, or it will be equal to 4 volt. So it has a voltage equal to 4 volt. Okay, and now here there is one resistance. Okay, it is 1K, and we have a voltage of 4 volt here. So what is the current flowing here? It is 4 by 1K, or this is equal to 4 milliamps. Okay, so there is, from this node there is a current flow here of 4 milliamps, and there is a flow of current of 2 milliamps here. So what is I naught? This I naught will be equal to the current 2 plus 4, that is I naught will be equal to 2 milliamps going through the feedback plus 4 milliamps going through the load resistance. So it is equal to 6 milliamps. Okay, so the answer is 6 milliampere. Yeah, okay, yeah, that's all.